To work as an electrician in Texas, you'll generally need a Texas electrician's license. Texas does not offer reciprocity for electrician's licenses from other states, so your out-of-state license isn't directly transferable. However, there are several avenues you can explore to gain employment in the electrical field while working towards obtaining your Texas license. One option is to apply for a temporary electrical permit. This permit is valid for 90 days and allows you to work under the supervision of a licensed electrician while you're in the process of obtaining your full license. To obtain a temporary permit, you'll typically need to provide proof of your experience and pass an exam. Another path is to seek employment as an electrical helper or apprentice. Many electrical contractors are willing to hire individuals with some electrical knowledge and experience as helpers or apprentices, providing on-the-job training and mentorship while you work towards your license. This is a great way to gain valuable experience and learn the Texas electrical codes and standards. To work independently as an electrician in Texas, you will need to obtain a master electrician license. This typically requires several years of experience working under a licensed electrician and passing a comprehensive exam that covers the National Electrical Code, or NEC, and Texas-specific regulations. Networking with contractors is also essential. Attend industry events, join local electrical associations, and reach out to contractors directly to inquire about job opportunities. Building relationships with potential employers can significantly increase your chances of finding employment. In your job search, emphasize your existing skills, certifications, and experience from your previous license. Highlight your knowledge of electrical theory, wiring techniques, and safety practices. Even though your out-of-state license isn't directly transferable, your experience and skills are still valuable assets. Several industrial electrical contractors in the Dallas and Fort Worth areas may be looking for qualified individuals. In Dallas, you might consider Markey Electric, Power Engineering Construction, and M&E Electric. In Fort Worth, you could explore opportunities with Amon Carter Electric, James Electrical Services, and Seco Electrical. So contact the Texas Department of Licensing and Regulation, or TDLR. Try calling at different times of the day as our phone lines can be busy. You can also use the TDLR online contact form or send an email to their electrician's email address. When studying for your Texas electrician's exam, familiarize yourself with the National Electrical Code, or NEC, which is the primary standard for electrical installations in the United States. Pay close attention to articles related to wiring methods, overcurrent protection, grounding, and bonding. Also, study the Texas Administrative Code, or TAC, which contains the state-specific rules and regulations for electrical work. Understanding these codes and regulations is crucial for passing your exam and working safely in Texas. Focus on understanding the requirements for conductor sizing, conduit fill, and box fill calculations. These are fundamental concepts that you will use every day as an electrician. Also, familiarize yourself with the requirements for different types of electrical equipment, such as transformers, motors, and generators. Be sure to understand the requirements for grounding and bonding electrical systems. This is critical for ensuring electrical safety and preventing electrical shock hazards. In addition to the NEC, you should also be familiar with other relevant standards, such as the National Fire Protection Association, or NFPA 70E, which covers electrical safety in the workplace. When you're working on electrical installations, always follow safe work practices. De-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses, and double-check your work to ensure that it's safe and code compliant. Consider different types of raceways. Firstly, rigid metal conduit, or RMC, which is a heavy-duty threaded conduit often used in industrial and outdoor applications. Secondly, intermediate metal conduit, or IMC, which is a lighter weight threaded conduit that can be used in similar applications as RMC. Thirdly, electrical metallic tubing, or IMT, is a thin-walled conduit that is commonly used in commercial and residential applications. Fourthly, flexible metal conduit, or FMC, is a flexible conduit that can be used in tight spaces or where vibration is a concern. Fifthly, liquid-type flexible metal conduit, or LFMC, is a flexible conduit that is designed to be waterproof and is often used in outdoor or wet locations. Lastly, non-metallic conduit, such as PVC, is a lightweight, corrosion-resistant conduit that is commonly used in underground applications. When selecting conductors, consider the ampacity, voltage rating, and insulation type. The ampacity of a conductor is the maximum amount of current that it can safely carry. The voltage rating of a conductor is the maximum voltage that it can withstand. The insulation type of a conductor determines its temperature rating and its suitability for different environments. Grounding is a critical safety measure that provides a low impedance path for fault current to return to the source. This helps to protect people from electrical shock hazards and prevent damage to equipment. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. This helps to equalize the voltage between different parts of the system and reduce the risk of electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When selecting overcurrent protection devices, it's important to choose the correct ampacity rating for the circuit. Branch circuits are the circuits that supply power to individual loads, such as lighting, receptacles, and appliances. Feeder circuits are the circuits that supply power to branch circuits. Service entrance conductors are the conductors that bring power from the utility company to the building. When calculating the size of conductors, it's important to consider the ampacity of the load, the voltage drop, and the ambient temperature. Also, refer to NEC Table 310.15 for conductor ampacity ratings. When installing receptacles, make sure to use the correct wiring configuration and grounding method. Ground fault circuit interrupters, or GFCIs, are required in certain locations, such as bathrooms, kitchens, and outdoor areas, to protect people from electrical shock hazards. Lighting circuits must be designed to provide adequate illumination for the space. Consider the type of lighting fixture, the wattage of the lamps, and the spacing of the fixtures. Electrical panels are used to distribute power to different circuits in a building. When installing electrical panels, make sure to follow the manufacturer's instructions in all applicable codes and regulations. Transformers are used to step up or step down voltage levels. When installing transformers, consider the voltage rating, kVA rating, and impedance. Motors are used to power a variety of equipment, such as pumps, fans, and compressors. When installing motors, make sure to provide adequate overcurrent protection and motor starting equipment. Control circuits are used to control the operation of electrical equipment. When designing control circuits, consider the voltage level, current requirements, and safety features. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dust. Electrical equipment used in hazardous locations must be specially designed and approved for those locations. In healthcare facilities, special electrical requirements are in place to ensure the safety of patients and medical personnel. Emergency power systems are designed to provide backup power in the event of a power outage. These systems are critical for hospitals, data centers, and other essential facilities. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. When installing renewable energy systems, follow all applicable codes and regulations and ensure that the system is properly integrated with the existing electrical system. The NEC is updated every 3 years, so it's important to stay up to date with the latest changes. Attend training courses and seminars to learn about new technologies and best practices. Working as an electrician requires a strong commitment to safety. Always follow safe work practices, use appropriate personal protective equipment, and double-check your work to ensure that it's safe and code compliant. With dedication, hard work, and a commitment to safety, you can build a successful career as an electrician in Texas. Good luck with your relocation and your job search. Also be sure to use the resources available, such as online forums, trade publications, and professional organizations, to stay informed and connected to the electrical industry. If you are performing work on dwellings, such as residential installations, there are parts of the NEC, National Electric Code, that address specifically items like, firstly, arc fault circuit interrupters, or RFCIs, are required in many branch circuits that serve dwelling units to protect against electrical fires caused by arc faults. Secondly, tamper-resistant receptacles are required in dwelling units to protect children from electrical shock hazards. Thirdly, smoke detectors are required in dwelling units to provide early warning of fires. Fourthly, carbon monoxide detectors are required in dwelling units to detect the presence of carbon monoxide gas. Also, understanding electrical drawings and schematics is a critical skill for electricians. Electrical drawings provide a visual representation of the electrical system, including the location of equipment, wiring, and circuits. Schematics are simplified diagrams that show the connections between electrical components. By carefully studying electrical drawings and schematics, you can understand how the electrical system is designed to operate and troubleshoot problems effectively. Also, NEC Article 250.66 provides requirements for grounding electrode conductor sizing. Also, NEC Article 250.122 provides requirements for equipment grounding conductor sizing. Lastly, understand the importance of properly torquing connections. Loose electrical connections can cause arcing, overheating, and even fires. Always use a torque wrench to tighten connections to the manufacturer's specified torque value. Lastly, electrical safety is everyone's responsibility. Never take shortcuts or compromise safety for the sake of speed or convenience. By following safe work practices, using appropriate personal protective equipment, and double-checking your work, you can help to prevent electrical accidents and injuries.